Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Okay, so let us see how many of us now. Good afternoon. Saya rasa kan dia macam number of waiting tu siapa yang log in ni orang panggil. Macam sign in kot tau. Kalau tak sign in dia tak tulis kot watching now. Don't know. Oh lupa. Tak payah pakai tak apa sebab hari ni tak bercakap. Selalu pakai Google Meet so kena cakap. Kena dengar. Okay, so now today we are going to learn a new subtopic 4.3 called the inverse matrices. So basically we have learned about matrices, a few properties of matrices as well. What are the zero matrix? What are the identity matrix? Row matrix, column matrix, square matrix, upper and lower triangular matrix. So we have learned about that before. And then yesterday, we learned how to calculate the minor, cofactor as well as the determinant. So today we are going to learn how to calculate the inverse matrix. Oh hi. Siapa yang say hi tu hi. Okay, so I think we need to wait a little bit. Ramai yang tak habis kelas lagi kot. Dua titik je dah harus hantar. Macam tu je. Ting, ting. Ting, ting. Bukan selalu awak hantar smile ke? Ada yang bracket tu. Hilang dah smile tu. Okay, so siapa yang dah ada kat sini, say hi. Hi. Okay, so now let us start then sebab saya kan habis lambat pula. So tak apalah, nanti slow-slow dia masuk kan. Okay, so now we are at subtopic 4.3 called inverse matrices. So the learning outcome for today is that you should be able to compute the inverse of a non-singular matrix using the adjoint method. Okay, so now the keyword is non-singular matrix and then adjoint method. So today we are going to learn what does it mean by singular, non-singular, and then what is the formula for adjoint method. Okay, so now finding inverse using the adjoint method, the inverse of a matrix is denoted by A to the power of -1, given that the determinant of A cannot be equal to 0. Okay, so A inverse is 1 over determinant of A times with adjoint of A. So one thing to take note is A to the power of -1 or A inverse is not equal to 1 over A. So A is a matrix, so we cannot have a division like this. So A inverse is not equal to 1 over A. Dia bukan algebra lah. Kalau algebra betul sama, but this is a matrices. So A inverse is not equal to 1 over A. Okay, so now determinant of A cannot be equal to 0. So why is that? Because if determinant of A is not equal to 0, A is called a non-singular matrix. So that means the inverse matrix does exist. So if the determinant is not equal to 0, A is a non-singular and the inverse matrix will exist. However, if the determinant is equal to 0, it simply means that A is a singular matrix. So the inverse matrix does not exist. So yang ni dia tak ada lah. A inverse tu tak ada. Inverse matrix exists. So that means we can easily calculate A inverse. Okay, so now inverse of a 2 by 2 matrix. So we are going to start from the lowest order. So 2 by 2. So if A is A, B, C, D, then the inverse of A is given by 1 over AD minus BC, and then D, negative B, negative C, and then A. Okay, so what is this? This is actually determinant of A. And this one over here is actually adjoint of A. So that is for a 2 by 2. Okay, so example 1, find the inverse matrix for A. A is 3, 1, 5, 4. Okay, so firstly, we need to calculate the determinant first, because if the determinant is equal to 0, it simply means that we don't have any inverse matrix. So calculate the determinant first. Okay, so determinant of 3, 1, 5, 4. So determinant of a 2 by 2 matrix. So A times D minus B times C. So 3 times 4 minus 1 times 5. So this is actually 12 minus 5, which is equal to 7. So I do know that the determinant is not equal to 0. I definitely have the inverse matrix. So let us substitute into the formula to find out the inverse matrix. Okay, so calculating the adjoint of A. So adjoint of A is D, negative B, negative C, and A. So this is A, B, C, D. So change the place for A and D. So A will go down, D will go up. So that is how we have D, A over here. For the B and the C, we simply times with negative. So negative B, negative C. So negative 1, negative 5. 4, negative 1, negative 5, 3. So now let us substitute into the formula. 1 over determinant of A times with adjoint of A. So we got 1 over 7, 4, negative 1, negative 5, 3. So times everything with 1 over 7. So this is our A inverse. 4 over 7, negative 1 over 7, negative 5 over 7, 3 over 7. Okay, so that is A inverse. So now, this is for a 2 by 2, so that will be quite easy for us to calculate the adjoint matrix. So let us see what happens if we have a 3 by 3 matrix. Okay, so let's see, be the cofactor matrix of A. Then adjoint of matrix A, ADJA. So ADJ correspond to adjoint. So adjoint of A is defined as the transpose of the cofactor matrix. So cofactor, find out the cofactor and then you transpose them. So that means adjoint of A, cofactor transpose. So do make sure to calculate each cofactor. So C11, C12, C13, C21, C22, C23, C31, C32, C33. Once you have everything, you transpose them. So that will simply be equal to CJI. So kita akan pusing lah row dengan column. Okay, so now please do remember the formula for the cofactor. Negative 1 to the power of I plus j, mij. So it will become positive m11, negative m12, positive m13, negative of m21, positive m22, negative of m23, positive m31, negative m32, positive m33. Okay, so now let us try one example. So given that A is 1, 2, 3, 3, 2, 4, 1, 1, 3. Okay, so find the adjoint of A. So do remember adjoint of A, that is equal to cofactor transpose. So from this A, you have to calculate what is the cofactor. Once you have the cofactor, we will transpose them to become the adjoint. Okay, so I'll give you around 4 minutes for you to calculate the cofactor and then transpose them to calculate the adjoint. So 4 minutes starting from now. Cofactor kira hati-hati semua orang. When you calculate the cofactor, be extra careful, especially when you are deleting the row and the column. Be careful. Make sure row yang betul, column yang betul. And when you times them, again be careful if you have the minus sign. Mana orang lain pergi ya? Pelik pula. Okay, 20 seconds to go. Okay, done. Right, so now let us check the cofactor that you have. Okay, so A is 1, 2, 3, 3, 2, 4, 1, 1, 3. Okay, so C 1, 1, deleting first row, first column. So we got 2, 4, 1, 3. So we have to calculate the determinant of 2, 4, 1, 3. So the answer is simply equal to 2. So we got 6 minus 4, so the answer is 2. So now C1, 2. So deleting first row, second column. So we are going to get 3, 4, 1, 3. And then of course AD minus BC, AD minus BC, 9 minus 4 times with negative 1. So it will become negative 5. And then C1, 3. Deleting first row, third column. So we got 3, 2, 1, 1. And then again AD minus BC, so 3 times 1 minus 2 times 1. So 3 times 1, 2 times 1. So we got 1 as the answer. Now 3 to 1. Deleting second row, first column, 2, 3, 1, 3. So 2 times with 3, 1 times with 3, and then once you have the answer to this, multiply them with negative 1. So it will give you negative 3. C2, 2, so deleting second row, second column. So 1, 3, 1, 3. So again, AD minus BC. So 1 times 3 minus 3 times 1. So it will become 0. And then C2, 3 minus deleting second row, third column. So 1, 2, 1, 1. So AD minus BC, A times D, B times C. So 1 times 1, 2 times 1. And then don't forget the times with negative 1. So we are supposed to get 1. So now the last three, so C3, 1. Deleting third row, first column. So we will get 2, 3, 2, 4. And then of course again AD minus with BC, so 2 times 4 minus 2 times 3. So the answer is simply equal to 2. C32, deleting third row, second column. So 1, 3, 3, 4. And then again AD minus with BC, so 1 times 4 minus 3 times 3. Once we have the answer to that, don't forget to times with negative 1. So it will become 5. And then C33, deleting third row, third column. So 1, 2, 3, 2. And then AD minus with BC. So 1 times 2 minus 2 times 3. So it will become negative 4. Okay, so once we have all the cofactors, so now let us substitute into one big matrix called the cofactor. Tadi kita dapat satu-satu kan, so ini kita masuk dalam ni lah. Okay, so now adjoint of A is equal to cofactor transpose. So we write down our cofactor and then write down the T because we have to transpose them. So transpose simply means that we have to change from row to column. Okay, so take the first row. So 2, negative 5, 1. That one will become the first column. Take the second row, negative 3, 0, 1. So it will become the second column, negative 3, 0, 1. Take the third row, 2, 5, negative 4. And it will become the third column, 2, 5, negative 4. Okay, so done with this example. Let us go to the next one. Given P 122, 2, 10, 5, 1, 3, 3. So now we got to find adjoint of A. So again, you have to calculate what is the cofactor. And once you have the cofactor, adjoint of A is simply cofactor transpose. So we have to write down the cofactor matrix and then transpose it to get the adjoint matrix. Okay, so now that is P 122, 2, 10, 5, 1, 3, 3, and this is the formula for the cofactor. Okay, so cofactor, so this is C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay, so C11, that is the positive of M11. So deleting the first row, the first column, that will give us 10, 5, 3, 3. And then for M12, deleting first row, second column, first row, second column. So it will give us 2, 5, 1, 3. And then of course you do the AD minus BC, you're going to get the value which is negative 1. And then C13, deleting first row, third column. So it will give you 2, 10, 1, 3. So 2 times 3 minus 1 times 10. So this is 6 minus 10, which is simply equal to negative 4. Okay, so now I'll give you a few minutes for you to calculate up until C33, what is the value. So saya bagi masa dalam 3 minit macam tu ke? Cuba try dulu. Ten seconds to go. Okay, done. Okay, so now let us check what is the value for C21. Okay, so deleting second row, first column. So 2, 2, 3, 3. That will become 0. Deleting second row, second column. So 1, 2, 1, 3. So 1 times 3 minus 2 times 1. So it will become 1. And then C2, 3. So deleting second row, third column. So 1, 2, 1, 3. 1 times 3 minus 2 times 1. So 3 minus 2, 1 times with negative 1. So it will become negative 1. And then C31, deleting third row, first column. So 2, 2, 10, 5. 2 times 5 minus 2 times 10. So that will give us negative 10. And then deleting third row, second column. So 1, 2, 2, 5. 1 times 5 minus 2 times 2. So that will give us negative 1. And then C3, 3. So deleting third row, third column. So 1 times 10 minus 2 times 2. So it will become 10 minus 4, which is simply equal to 6. Okay, so the cofactor is 15, negative 1, negative 4, 0, 1, negative 1, negative 10, negative 1, and 6. So now the formula for adjoint. So adjoint is cofactor transpose. So now for this cofactor, we're going to transpose them. So take the first row, change it to the first column. So 15, negative 1, negative 4, 15, negative 1, negative 4 as the first column. 0, 1, negative 1 in the second row. That one will become the second column over here. Third row, negative 10, negative 1, 6. That one will become the third column. Okay, done. Next. Okay, so there are three methods to obtain the inverse of a matrix. There are three methods. So you can use the adjoint method where A inverse is actually 1 over determinant of A times with adjoint of A. So that is the first method. The second method is use the property where we have AB equal to KI, and then we can easily calculate what is A inverse and B inverse. So that is the second method. The third method is by using the elementary row operation, ERO. However, the last one, that will be discussed in tutorial. So I don't discuss them in class. You will discuss them in your, I won't discuss in lecture. I'll discuss them in tutorial. So siapa yang tutorial dengan saya rasa ada satu kelas kot. Saya dah bincang dah. Yang lain tu nantilah kita bincang. Okay, so now finding the inverse using adjoint method. So A inverse is 1 over determinant of A times with adjoint of A. Okay, so inverse of a 3 by 3 matrix. Find out the inverse for B. B is 1, 3, 2, 0, 2, 2, negative 2, negative 1, 0. Okay, so firstly, we got to calculate the determinant first, because if let's say the determinant is equal to 0, there is no inverse. So kalau determinant dia sama dengan kosong, dah tak di inverse lah. Tak di inverse, tak payah kira. Okay, so let us calculate the determinant first. So this is what happened when we expand along the first row. So A11, C11, A12, C12, A13, C13. So this is supposed to be a plus first. And then we change it to minus. So this is A11, M11 minus A12, M12 plus A13, M13. Okay, so A11 that is equal to 1. A12, so that is equal to 3. So this is A11, A12, and then 2 is A13. Okay, so in order to get M11, so we should delete the first row, the first column. So first row, first column. So first row, first column. We are going to get 2, 2, negative 1, 0. So 0, and then plus with 2. So that is how you end up with 2. M12, so deleting first row, second column. So we are going to get 0, 2, negative 2, 0. So this is 0 plus 4. So that is how you end up with 4. And then M13, deleting first row, third column. So it will become 0, 2, negative 2, negative 1. So 0 plus 4. So that is how you end up with 4. So we got 1 times 2 minus 3 times 4 plus with 2 times 4. So the determinant is equal to negative 2. So the determinant is not equal to 0. So that means we do have the inverse. So kena kira determinant dulu baru kita cari inverse. Okay, so now let us calculate the inverse. Okay, so we need to find out the cofactor of B. So this is your matrix B. So this is the sign for the minor. So now I'll give you a few minutes for you to calculate cofactor of B. So say, saya bagi 4 minit bagi saya minum air jap. 4 minutes for you to calculate the cofactor of B. Two minutes everyone. So do make sure you do know how to calculate the cofactor by now. If you still didn't know how to calculate the cofactor, you might need to do a bit of recap so you can watch the previous lecture, or you can look at the previous example. I think in example 2 and 3 I do quite a lot of cofactors, so you might want to look at them. Twenty seconds to go. Okay, so now let us go to the cofactor. Okay, so basically this is what happened when you delete the row and the column. Okay, so now do check with yours. Do you get the same value with mine or not? So this is my cofactor. 2, -4, 4, -2, 4, -5, 2, -2, 2. So check jap, sama tak? Okay, so now once we have the cofactor, let us calculate the adjoint. Okay, so cofactor is 2, negative 4, 4, negative 2, 4, negative 5, 2, negative 2 and 2. So that means the adjoint. So we simply take the transpose of the cofactor. So 2, negative 2, 2, negative 4, 4, negative 2, 4, negative 2 and 5. So we change from row to column, change row 2 to column 2, change row 3 to column 3. So those are the adjoint. And then to calculate the inverse, so the inverse is simply 1 over determinant of A times with adjoint of A. So the determinant we already calculate previously, which is 1 over negative 2 times with the adjoint 2, negative 2, 2, negative 4, 4, negative 2, 4, negative 5 and 2. So that means the inverse of the matrix is negative 1, 1, negative 1, 2, negative 2, 1, negative 2, 5 over 2, negative 1. So if you do have some fraction, that is fine. So just leave them as the fraction. So kadang-kadang memang kita akan dapat answer dalam fraction lah untuk B inverse. That is totally fine. It doesn't really matter. So you can have numbers. By numbers, I mean natural numbers. Or you can have integers. Or you can have something with rational. That is fine. Okay, so now we have learned how to do the B inverse. So let us proceed to the next one. Oh wait, I should give you some time. Snap, snap. Okay, so 5 seconds for those who haven't copied down. So 5, 4, 3, 2, 1, done. Okay. Properties of the inverse matrix. So we have a few properties. The first one is that if we have A inverse and then you take the inverse of that matrix, it is simply equal to A. If you have A transpose and then you want to take the inverse of the A transpose, that is actually equal to finding out the inverse for A first before you transpose them. So it will be equal. If we have AB inverse, so you do times A and B first before you calculate the inverse, that is actually equal to finding out the inverse for B and then finding out the inverse of A and then you times them. Okay, so now another one, this is quite crucial. So determinant of A inverse, this is 1 over determinant of A. So A inverse is not equal to 1 over A. However, if you take the determinant of A inverse, that is actually equal to 1 over determinant of A. So dalam determinant dia betul lah. Okay, next. Finding the inverse by using the property AB equal to KI. So if AB equal to BA equal to I, what can we say is that A is definitely equal to B inverse and B is definitely equal to A inverse because only A times with A inverse can get I and only B multiply with B inverse can get I. So that means B must be A inverse and A must be B inverse. Hence, if AB is equal to alpha I, then that means A inverse is equal to 1 over alpha multiplied with B. Okay, so now AB equal to alpha I. So I want to calculate A inverse. So let us times with A inverse. So A inverse AB equal to alpha A inverse. A inverse times with A, this is simply equal to I. So B is equal to alpha A inverse. So if I want to find out what is the A inverse, I need to get rid of the alpha. So we got to multiply with 1 over alpha on the left hand side and right hand side. So that is how we get A inverse equal to 1 over alpha B. So ini macam mana kita derive dia lah. So we should multiply with A inverse on left hand side. Be extra careful when you want to multiply with A inverse. Do multiply on the left hand side because only A inverse times with A can be simplified. Kalau kita terdarab sebelah kanan, nanti jadi A, B, A inverse. Yang ni tak boleh simplify. So be extra careful. Where do you multiply the A inverse? Okay, so now the same procedure will happen if you times with B inverse. So B inverse is equal to 1 over alpha multiply with A. Okay, so now if AB equal to I, where A and B are square matrices, then B is called the inverse matrix of A and is written as A inverse. Okay, so now given that A is 4, 1, 2, negative 2, 3, 1, negative 1, 3, 1, and B is 0, negative 5, 5, negative 1, negative 6, 8, 3, negative 13, negative 14. Find AB as single matrix, deduce A inverse and B inverse. So from this question, I do see that I have to calculate A times B first. So once I have A times B, I have to deduce A inverse and B inverse. So by deducing that mean I should use the product from A times B. So maksudnya A times B ni mesti dapat satu constant darabkan dengan identity matrix. Okay, so I'll give you a few minutes for you to calculate A times with B and then we got to deduce what is A inverse and B inverse afterwards. So to times them, I think I'll give you around 4 minutes for you to calculate what is the answer when you do A multiply with B. So you can write down your answer. For example, AB equal to I, AB equal to 4I, AB equal to 3I and so on. Negative 2I ke apa ke? So tulis dalam bentuk tu dekat ruangan chat. So 4 minutes starting from now. Lajunya wait AB equal to 5I. Sekejap kita bagi orang lain kira juga. Sebab ada yang tengah duk buat tu lagi. Duk buat garis lagi. But wait, since you already have AB equal to 5I, can you deduce what is A inverse and B inverse from that? 30 seconds to go. For those who haven't calculated, please finish calculating A times B. Eight, seven, six, five, four, three, two, one. Done. Okay, so now let us check. Is it true AB equal to KI? AB equal to 5I. Okay. So now AB, A times B. So the answer for this one, you take the row times with the column, row with column, row with column, and take the second row times with each column, take the third row times with each column, and then the answer to this is 500,050,005, which is simply equal to 5i. So betul lah, siapa yang dah dapat 5i, tahniah semua orang. Okay, next. Okay, so AB is equal to 5i. Therefore, to get the A inverse is actually 1 over 5 multiply with B. So you take B, so this is matrix B, and then we simply times them with 1 over 5. Okay, so how do we come out with A inverse equal to 1 over 5B? Okay, so we start with AB equal to 5i, and then we times with A inverse on the left hand side, left hand side. So left hand side, left hand side. Okay, so A inverse times with A, that is actually equal to identity. So identity times with B equal to A inverse times with 5. So now I need to make sure I have A inverse as the subject. So we should times with 1 over 5 to cancel out the 5 over here. So times with 1 over 5. So we got A inverse equal to 1 over 5B. So kita ambil matrix B kat sini. So this is matrix B. And then we times them with 1 over 5. So B inverse is 1 over 5 times with A. So the same procedure actually. So AB is equal to 5I. So times with B inverse. So B inverse equal to 5B inverse. And then B inverse, that is simply I. So A is equal to 5 B inverse. So in order to get rid of the 5, I have to times with 1 over 5. So that is how B inverse is 1 over 5 multiplied with A. Okay, so now let me see. I think that's it for this lecture. Okay, so that's it for this lecture. We have already finished how to calculate the inverse using the first one, using the adjoint method, where we have to calculate the cofactor and then take the transpose of the cofactor to know the adjoint, and then you times with 1 over determinant of A. So that is the first one. So we have learned how to calculate the adjoint. We have learned how to calculate A inverse using the adjoint method, 1 over determinant of A times with adjoint of A. And then I should remind you one more, if the determinant is equal to 0, there is no inverse. If your determinant is not equal to 0, you will get some inverse. So do make sure to calculate the determinant first. Okay, so those are a few exercise, but never mind. We will discuss them later on in our tutorial class. Okay, so with that, I'll see you guys next week for lecture. So jumpa minggu depan lah untuk kuliah yang last. So the last lecture for chapter 4 next week on Sunday, 4 o'clock. So I'll see you guys next week. Bye everyone. Have a nice day.